So your hook, which I hope we will have great fun with, has to do with this hunter who is hunting for monkeys. This might very well be a tranquilizer dart, and he's looking after the monkey's health. This is a monkey hunter, but it's perhaps hunting for humans. We want to do this monkey hunter, and it is known that when he shoots at the monkey, this looks like a blowgun, but suppose it was a powder actuated weapon, that when he made the bang to shoot, he knows that the monkey will let go of the tree and fall. So knowing that the minute he shoots, the monkey is going to let go of the tree, should he aim above the monkey, that's aim along 1, or at the monkey, that's aim along 2, or below the monkey, aim along 3. And you are to choose one of those. You can circle it there on your worksheet. And we will come back and play with that when we get into class. This is an image from your textbook. It's in many textbooks. You need to understand that this has been made stroboscopically, so there is a light that is flashing at regular intervals, and every time it flashes, the film is exposed, and you can see where these two balls are. This mechanism here launches the two balls simultaneously. One ball is kicked out of the launcher and the other is dropped from the launcher, but at exactly the same moment. And you ought to examine the picture and see what truths it has to offer. What is the important details that are shown here in the stroboscopic picture? Given that you have done the trajectory lab, it ought to be easy for you to say these two things: that the rate at which the ball falls is not affected by how fast it is going horizontally, that these two balls fall at the same rate, even though one is moving horizontally and the other one is not. And the second point is that the rate at which the ball moves horizontally, if you were to draw vertical lines through these balls, you would find that it moves at the same rate horizontally, even though it is falling faster and faster. So to repeat, that the rate of fall is unaffected by the horizontal velocity, and the horizontal velocity is unaffected by the rate of fall. I hope that's the way it is on your worksheet. I can fix that. Well, given that the horizontal motion is not affected by the vertical motion, and the vertical motion is not affected by the horizontal motion, this is the basis on which you will do projectile problems. That first you would recognize it as something that has been projected, thrown through the air, and then you will say, okay, I'm going to do this as a projectile problem. You will write down an equation for the horizontal displacement and an equation for the vertical displacement, and realize that those two equations are independent of one another, but are happening simultaneously. It is the same time in both equations. Horizontally, because there's no force, there will be no acceleration. So this equation gets simplified. And vertically, the acceleration is going to be 9.8. And so the two equations come to look like this. And these will be the two equations you will write down whenever you are doing a projectile problem, that you might want to assert that you have the right to this equation because there is no change in acceleration, and the same goes here. Or you could just state that the acceleration here is 0, and it's constantly 0, and the acceleration here is negative 9.8, and it's constantly negative 9.8. That would give you the right to do those two equations. So for example, here is your first problem: that the ball is launched from a height. How far away horizontally will it land? and you want to get this information from this picture, that what is going on is the ball is launched horizontally, then it follows a parabolic arc, and it lands 8 meters lower, since it started at a height of 8, launched horizontally. And the question is, what is this distance here? How far did it move horizontally while it was moving vertically down by 8 meters? So you put all of the data that you know here into those spots, and then you take those two equations and you substitute the values in. You would do this equation here would have t as the only unknown, so you would work with the vertical equation to see how long it took for it to fall 8 meters. Then that same t is how long it was moving horizontally at whatever Vix is. So finally you could get delta x, which is how far away it moved horizontally. If you would circle that, and looking back here, you could see how many sig figs you're going to have in that answer, and you put the correct units. Second problem. Same two equations. You copy them down onto your sheet. That's there on your worksheet. You just have to look further up the sheet, but hopefully they come very familiar to you. This time the ball is kicked at 12, but at an angle of 30 degrees above. Well, it's flying through the air, so it's definitely a projectile problem. But remember, when we do projectile problems, we work with the horizontal and the vertical independently but simultaneously. So we cannot do anything with this 12 at 30. You would first need to do the trig of finding out what the initial horizontal velocity was and the initial vertical velocity was, given that the initial velocity was 12 at 30 degrees. And I'll do that for you. Here would be the results you would get of that bit of trig. Now you should be able to proceed to do the rest of this projectile problem, getting your answer to the correct sig figs and units. Here again we have going at the same initial velocity, so that the results you got in the problem above will still work for the initial velocities in the x and the y directions. But before you start to do the problem, consider this. How fast is it moving vertically when it reaches the top of its flight? That here's the projectile. How fast is it moving vertically when it is here? How fast is it moving horizontally when it is there? And then the question that really matters, how high will it be at that highest point? And what I would suggest you do is only pull vertical information here. Look at the vertical information that you have. Find an equation that fits that vertical information, including the question that's being asked, and plug in and solve. And you should be able to do that without breaking too much of a sweat. And that concludes the show.